So in the previous lesson, we talked about ratios, and ratios are just a way of comparing two different things measured in the same unit. So we're going to carry on with that conversation, and today I'm going to teach you how we can use ratios to solve problems. More specifically, we're going to talk about what a proportion is and how a proportion can be set up to help us solve problems when we know the relationship or the ratio between items. Okay, so when we take two ratios and we say that they have to be equal to each other, then we've created an equation, and that equation is called a proportion. So for example, over here I see that I have a ratio of 2 to 3, and I have another ratio that is 4 to 6. And since those two ratios are equal to each other, they're equivalent ratios, as soon as I put this equal sign in between, I've created a proportion. So the 2 to 3 ratio on its own and the 4 to 6 ratio on its own, those are ratios. But as soon as I equate those two ratios, I've created a proportion. Just remember that any ratio can be written also in fraction form. In fact, I will use ratios in fraction form for the lesson because I think it makes it easier to visualize the solution. Okay, so in our last conversation about ratios, we talked about the order that you state things in as being super important in letting the reader understand fully and correctly what it is that you're trying to say. So, for example, in class we talked about the ratio of boys to girls, so boys to girls being something like, 17 to 5. Well, if I were to ask for the ratio of girls to boys, if I were to say 17 to 5, that would be incorrect, right? That would not be right. However, I can write the ratio of girls to boys if I know the ratio of boys to girls. I just need to make sure that I put the values in their correct position so that whatever the information is that relates to girls is on the same side as the value, the measurement for girls, and likewise for boys. Okay? Now, moving forward, when we're writing out proportions, that's still going to be extremely important to pay attention to, and I'll show you through an example what it is that I mean. So let's look at an example, and that will help me to clarify what I mean by representing the order properly. So let's use an example that involves baking. So let's say in a particular recipe, you know that the sugar to flour ratio is 1 to 2. So when I read it like that, I can see that the sugar, the information relating to the sugar is going to be first in my ratio, and the information relating to flour is going to be second in the ratio. So really, if I'm talking about cups of sugar to cups of flour, I need 1 cup of sugar for every 2 cups of flour, and that's how I read that. So the question is saying, well, how much sugar will be needed with 10 cups of flour? All right, so I'm going to set up a proportion. So I'm going to be very, very careful when I set this up. I'm going to start with what I know. I find sometimes it's helpful to actually put the words sort of to the side in the margin to help keep me, remind me of what belongs on which side of the fraction that I set up. So I know that, sugar to flour, okay, everything pertaining to the sugar is going to be on the top side of my proportion, and everything related to the flour is going to be on the bottom side. This isn't actually part of my equation, but it's important to keep things organized. So I know that sugar to flour, well, that's 1 to 2. And so what else? What other piece of information do I have for the second proportion? Well, I also have the fact that I have 10 cups of flour. And so because I have information about flour, and that's going to go on the bottom half of my fraction, that's where my 10 cups are going to go. And so what am I looking for? Well, I'm looking for the corresponding amount of sugar. So I can use a variable to represent that. Since it's sugar, I might want to use the variable s. But if you're more comfortable with using x as an unknown, then by all means go ahead and do that. But that's what we want to do first. We want to set that up properly. And that's really key to getting your question, your problem correct. Okay, so just to remind you again, I need to make sure that when I set up my proportion, the parts of it that relate to a particular substance need to be on the same side of the fraction. So notice that the 1 relates to the sugar and the unknown relates to the sugar. Okay, the 2 cups of flour and the 10 cups of flour. Okay, if I set it up improperly like I have over here, then I have this 10 cups of flour being related to or equivalent to, in proportion to, my 1 cup of sugar, and that's not correct for this situation. Okay, so now that you've set up your proportion, there are multiple ways that you can solve for your unknown, for the amount of sugar that you need to go along with your 10 cups of flour. Right, so I've written a few notes here in the margin. You need to, keep in mind that this is a really simple example, and I'm going to show you how you can solve it simply without actually working through this instruction to cross multiply. I'm going to start with that first, but I want you to keep in mind that these are really nice and friendly numbers. They're easy to work with. Sometimes you might be working with decimals or really unfriendly numbers, and that means that you need a strategy that will work in that circumstance that will be really efficient. All right, so let me show you what I mean. So we have equivalent fractions here. We want to make sure that the left side of this proportion is equal to the right side of the proportion. So it's helpful sometimes in simple cases to view this as a case of equivalent fractions. And so I would say to myself, well, is there a number that I can multiply by 2 to give me 10? And I know that that number is 5, right? 2 times 5 will give me 10. So remember that whatever I do to the top portion of a fraction, I need to do to the bottom part, so denominator and numerator. So I'm going to multiply the 1 by 5. And that gives me what the value of x is. So I can now, conclude that x has to be 5. I think that's fairly obvious. So what that tells me is that therefore 5 cups of sugar are needed to go along with those 10 cups of flour, right? But again, I want to demonstrate what to do if you're stuck with some really nasty numbers. And the process is actually quite simple. It involves algebra. So some of you are quite comfortable with that and may find that that works well for you. So how do you cross multiply? I'm going to show you. So it doesn't matter whether you start with the denominators or the numerators, but you need to multiply across from the denominator or the bottom of one fraction to the top of the other. So 1 times 10 gives me 10. And then you need to multiply the denominator of one fraction by the numerator of the other. So that gives me 2x. So now I really just have an algebraic equation here. I have 10 equals 2x. We've seen cases like this time and time again. To figure out what the unknown value of x is, I'm going to divide by 2 to cancel the 2's out, because 2 divided by 2 will leave me with just x or 1x. And then I divide by 2 on the other side. So 10 divided by 2 will give me 5. So I ended up with the same answer. I need 5 cups of sugar no matter what method that I used. You can see that for this example, it took me a lot longer to use the algebra, but it probably will not. It'll be more efficient when you end up with having to use more complicated numbers. So here are a couple of examples that where the numbers maybe aren't so friendly. The first one, you can choose to go about this by looking at equivalent fractions, or you can do the cross multiplication method. I would like you to pause the video and try these questions yourself and then check your answers. I'm going to go ahead and solve. So I'm going to cross multiply. So x times 3 gives me 3x. And 5 times 72, that's a number that I might want to use a calculator to figure out. Typing that in. Of course, some of you may know that off the top of your head. Fantastic. 5 times 72 gives me 360. So 3x gives me 360. So to solve for x, I'm going to divide by 3 on each side. And that gives me that the value of x is 120. So, that's a proportion or an equation that can be solved by cross-multiplying, it's not a problem. The value of x doesn't really mean anything in this situation until I decide that it does. All right, on to the next question. So I'm going to cross-multiply. 7 times x gives me 7x. 2 times 10 gives me 20. These numbers are not so friendly. There's no number that I can multiply 7 by to give me 10. So I'm probably going to end up with a decimal when I solve this. So cross-multiplying was a great choice. Then, dividing by 7, my value is, well, x does not divide evenly by 7. That gives me roughly, if I'm rounding to the first decimal place, I get around 2.9 roughly. So there we go. And so I wouldn't have been able to get the answer by using equivalent fractions. All right, so lots of words in this next example. Always really important to read a word problem a couple of times to make sure we understand what they're asking of us. And, you know, in this case, I know that's going to be a proportion because that's the section that we're looking at, but you may want to adopt another strategy. I'm going to show you how to use proportions to solve this. So it says a 4-liter can of paint covers 360 square meters. Okay, that's an area. How many liters of paint, how many liters are needed to cover a room that requires 900 square meters to be painted? All right, so I start by kind of looking at what it is I know and how I can use that to set up a relationship or a proportion between these values. Okay? So I know that 4 liters covers 360 square meters, right? So I'm looking at liters in this case. Okay, the liters needing to cover a certain amount of area, square meters. So I know that 4 liters will cover 360 square meters. But I want to know how many liters, so my unknown is how many liters I'm going to need if I have a different amount of area to cover. So there I've set up my proportion. That's the thinking part that requires you to really figure out how you're going to solve the problem. Now that we see this, we have a proportion. Just remember that, you know, the square meters and the liters don't really impact my answer at all. They're just kind of there to help you remember what piece of information is corresponding in this case. So I'm going to cross multiply. 360 times x gives me 360x. And 900 times 4, well, I know that 9 times 4 is 36. So 900 times 4 is going to give me 3600. So, if you need to use your calculator to solve this, go right ahead. I'm going to divide by 360 on both sides. And that is going to give me 10. So my value of x is 10. And so now I need to go back and remind the reader what it is that that 10, that value of 10 for x, is supposed to represent. Well, in this case, I want to know, well, how many cans of paint do I need for 900 square meters? So I need to answer that. So the 10 right here is telling me that I need 10 liters of paint, right? So therefore, 10 liters of paint are needed. Right? So they haven't asked me how many cans of paint I need. That would be another proportion, and that's a separate question. So be really careful to read what the question is asking of you so that you're able to answer it properly. Here is the practice work for this section of our chapter. Make sure that you complete it and check your answers using our online student workbook solutions manual located on my website. Please see me if you have any questions.